Hello, hello, hello. Welcome to lesson 2.6, Investigating Paths of Energy. Whew. Hey, lucky you, we're skipping something today. So pay attention and you'll find out what. Some of you aren't going to watch the video and you're going to do it anyway, and you'll be like, oh man, I should have watched the video. I know. Hey, our investigation question is actually different today. Look at that. Why does an increase in carbon dioxide or methane result in more energy entering than exiting the Earth's system? We're going to talk about this. Why does that happen? We've been looking at, okay, well, we noticed that it does happen. You have more carbon dioxide, you have more methane. It looks like, okay, less energy is exiting, more energy is entering, which is increasing Earth's temperatures. But why? Why do these gases do that? So that's exactly what we're going to look at today. So good question, you. Let's go ahead and jump to our warm-up. Oh, look here. Oh, technical difficulties. How many of you have been seeing that lately? Jeez. 2.6, Investigating Paths of Energy. Here's our warm-up. I love the pictures here. Don't you like the artwork on Amplify? It's pretty good. Let's get rid of the instructional guide. Here we go. Review your original response to this statement from the anticipation guide. Remember, way back in the beginning, we had this question. We had to say whether or not we agreed or disagreed. It is possible for gases in the atmosphere to change the behavior of energy on Earth. Great. What was your original statement? That's what you're going to write right here. Do you currently agree or disagree? There's no middle option. Rats, but I don't like committing. Have your views changed? Do you think differently now that we've gone through some of this? And then what evidence do you have to support your current thinking about this claim? Please explain. Hey, evidence. We got the sim. We've got some of those readings that we've done. And just some of the other information that we have, looking at the data, those graphs that we saw, that you could add in here as well. So go ahead, take a moment, answer that warm-up question right now. Hit pause. So let's talk about this really quick. It is possible for gases in the atmosphere to change the behavior of energy on Earth. Hey, we just said this in our introduction. Yeah, we noticed that, if you add more carbon dioxide or methane to the atmosphere, it appears that energy sticks around longer. It has trouble exiting Earth's system. So for some reason, energy is not exiting, but it's staying around. And again, that's what we're exploring today. So let's go to the sim. Oh boy. Hey, let's do this. Let's read the directions. Use the simulation to investigate this question. What happens when energy interacts with carbon dioxide or methane in the atmosphere? That's what we're trying to figure out. What is happening? Discuss with your partner, you don't have one, and record your initial claim below. What's my initial claim? Write that right here. What do you think is going to happen when energy interacts with carbon dioxide or methane? Decide which partner will investigate carbon dioxide and which one will investigate methane. You can choose which one you want to investigate, carbon dioxide or methane. Set the gas you're investigating to maximum and the other gases to 0. So let me actually jump over to the sim right now. All right, let's say I'm doing carbon dioxide. I want to put that all the way to maximum. And everything else it said, go to 0. What else does it say now? Press on the eye icon to make that gas you're investigating visible. Okay, how do I do that? What's that? Oh, this eye right there. But look at that. They all kind of pop up. That's nice. Choose an energy arrow that is moving away from Earth. Press on the arrow to activate the tracking function. The other arrows will fade. And this arrow's track will be visible. Well, that's cool. So I want to find one that's moving away from Earth. Hey, how about that one? That one's moving away from Earth, right? That away, yeah. And look, all the other ones, they kind of disappeared. Well, that's cool. They all faded. Press play and observe. Okay, well, before I do that, I kind of want to read the next thing. If your energy arrow leaves Earth's system, choose a new one. Be patient. It may take a few tries before you capture an interaction. Capture an interaction. I'm playing Pokemon Go with my kids, and so whenever I see capture, I'm thinking, I'm all out of Pokeballs and I need to go to a Pokestop and get more because I'm sure not paying for those things. 8, if your energy arrow interacts with a gas, continue observing until that energy arrow leaves the Earth system, then pause and take a screenshot. Okay. Describe what happened and upload the screenshot below. Try to capture at least 3 interactions. What the heck is it talking about? Well, let's take a look. What does it mean in interaction? What you're doing is you're watching this arrow, and you're going to try to see if it will actually come into contact with one of these carbon dioxide molecules. And you're trying to describe, all right, what happens when that happens? So let's go ahead and hit play. Did it interact with any of those molecules? Nope, sure didn't look like it. Let's reset this bad boy. Let's turn up our carbon dioxide again. Everything else down. Choose. There we go. There's an arrow that's moving away. Let's hit play. Did it interact with? Nope, didn't interact with anything. Okay. Maybe I can just choose another arrow. Will that work? Oh, I can. I don't have to keep on resetting it the whole time. But there's no arrows moving away from Earth. What do I do? Well, I'll just okay. Here we go. There's an arrow moving away from Earth. I'll use that one. And oh gosh darn it. Nope. Let's try. Ooh, this is going to be my lucky arrow right there. What is happening? Stop it. Right there. What happened? Oh, there we go. Nope, that wasn't my lucky arrow. Let's find a... Ooh, look at this one. It looks like it's right about to hit that carbon dioxide right there. Boom! We did it. Look at that. We got one. And look what's happening. It hit it, and then it came back down here, and now it's doing... Oh, there it goes. It goes back out into outer space. Okay, we did it, folks. So, take a screenshot. Once you take a screenshot, upload it down here. That was interaction 1. And then just, right there, and describe what you observed. What happened? What did we see happen? Well, I might say the energy hit the carbon dioxide and then came back down to Earth. Was that at some weird angle? It wasn't even the same angle that it hit that carbon dioxide. And eventually, it stuck around down on Earth's surface for a while and eventually left the atmosphere again. Okay. All right. So you want to do that how many times? 1, 2, 3, 4. Try to do it 4 times and see what happens. Hey, what's number 2 say? Discuss the results of your investigation with your partner. You don't have a partner. Was your initial claim accurate? Based on your investigation, how would you answer the question now? How would you answer this question now? What happens when energy interacts with carbon dioxide and methane in the atmosphere? Hey, go ahead, do that. Play around with the sim right now. Pause. Oh boy, next thing, number 3, it's the investigating with the energy token model. Hey, guess what? You don't have to do it. It is just over complicated to try to explain right now, and you don't have a partner to play with. So, let's just do this. We can still go to part 2 on this, and we can still answer this question. Why does an increase in carbon dioxide and methane result? Okay, that was our investigation question. Based on your investigations with the sim and the energy token model, which of the following statements is most accurate claim? So you can still answer this just based on what we did with the sim, and then use the answer you chose to explain why increased carbon dioxide or methane leads to an increase in temperature. So again, based on what we saw in the sim, why would increased carbon dioxide or methane lead to an increase in temperature? Go ahead and answer those questions right now. Pause. Hey, can we talk about this answer really quick? It's C, okay? Increased carbon dioxide or methane redirects some energy that was leaving back to Earth's surface. So that energy was trying to escape. It was doing the responsible thing. It visited Earth for a little bit, and it was going to leave and say, all right, well, it was nice seeing you. I'm out of here. What happens? Carbon dioxide and methane stop it right at the door, and they redirect it back down towards Earth's surface. Now, sometimes it doesn't go right back down to Earth's surface. Sometimes they redirect it back out into space. But the point is, sometimes they do redirect it back down to Earth's surface. So, using the answer you chose to explain why increased carbon dioxide or methane leads to an increase in temperature, the more energy that gets absorbed by the Earth's surface, the higher the temperature of the Earth is going to get. Let's look at the homework. You're going to jump back in the modeling tool, but it looks a lot different now. We got new features. So it says there's some new things you can do with Earth's changing climate modeling tool activity. Make sure you click on this link for the modeling tool, the specific one that we're using, because they're all different. In this version of the modeling tool, the panels don't represent before and after like we've done before. Instead, you can use the 2 panels to show how 2 different gases affect energy. For example, you can show energy is affected by nitrogen dioxide in one panel, carbon dioxide in the other. Draw the path of energy and drag out individual gases. Play around with these new features. Use them to draw some different ways you saw energy move and interact with the gases in the sim today. Okay. Goal, what is the goal? Explore the tool. Okay, we're trying to familiarize ourselves with these new features, but we're also trying to show what we saw in the sim. So let's go ahead and jump to our modeling tool right here. All right, so it said go ahead and drag some, I'll drag some methane out. Oh, look at that, cute little methane X's. Nice. Now there's a reason they look like that. And okay, so energy. Here we go. I got energy. Oh, I know what I'm going to do. I'm going to show energy coming in from outer space. Look at that. And I'm going to draw more energy leaving Earth. But oh no, it hit one of my methane. And now what I'm going to show that it gets redirected back down to Earth, just like that. Yeah. That's kind of what we were seeing, isn't it? That the energy came in, interacted with one of these gases, and then was redirected. Sometimes it did go back out into outer space, but sometimes it came back down to Earth. So, hey, do this. Take some screenshots. Make sure you hit hand in, please. Hit hand in for this, and then yeah, and then you're good to go. So, see you next time.